Hello viewers, I welcome you all to my channel Fundamentals of Optometry. Today I have come up with the second part of the optical properties of contact lens. I have already shared the link of the first part in the description box which you can refer to for a better understanding, and I would request you all to watch the video till the end to get a very clear understanding of the entire optical properties of contact lens, because there are many things to know and understand about these type of properties of contact lens. And if you like my video, then please do like and subscribe to my channel so that I can come up with more such new academic videos for all. Now, just for the sake of recapitulation, in the first part I have already discussed about the back vertex power calculation of contact lens, the magnification with contact lens, and the change in the accommodation and convergence through contact lens. So if you refer to that presentation, you'll be able to understand everything in details and in a very easy manner. In the second part, I'll be discussing about the tear lens power, the visual field with contact lens, the aberration change with contact lens, astigmatism or toricity neutralization, and over refraction. So let's check out one by one. So what is tear lens? Tear lens is basically the meniscus shaped layer of tear film which is formed between the anterior corneal surface and the posterior surface of the contact lens, as you can see in this picture. Now, when we are placing the contact lens over the cornea, that time the tear lens over the cornea, that which is called the precorneal tear film, it distributes itself in two places. One is over the anterior surface of contact lens, which is called the pre-lens tear film. Another between the posterior surface of contact lens and the anterior surface of cornea, which is called the tear lens, the meniscus shaped tear lens, or the post lens tear film. Okay, well, with any kind of name you can address it. Now, when we are placing a soft lens over the cornea, then what happens? The soft lens is very soft and flexible in nature. As a result, it can very easily conform itself according to the shape of the anterior corneal curvature. Therefore, the post lens tear film or the tear lens between the contact lens and the cornea is almost zero, or it is zero. Okay, but in case of RGP lens fit, what happens? The tear lens power does exist because RGP is not as flexible or soft as a soft contact lens. Therefore, based on the fit of RGP lens, the tear lens power will also vary, whether it is a flat fit or a stiff fit or an optimum fit. Based on that, the tear lens power will also vary. So this is a very important thing to understand, that because tear lens is meniscus in shape, so automatically it will have some power in it. It can either be a plus power or a minus power or a plano power. Now plus power comes in tear lens if the contact lens fit over the cornea is a steeper one. So in case of tight fit, what happens? The post lens tear film takes a convex meniscus shape. As a result, the plus power gets induced there. Similarly, if the lens fit is flatter over the anterior corneal surface, then the meniscus that gets formed is concave in nature. As a result, the minus power gets induced. But in case of optimum fit, what happens? The tear lens power is either a negligible one or a plano one. Therefore, we have to understand a very important thumb rule, that if there is a 0.05 millimeter deviation in the back optic zone radius, which is the base curve of contact lens, because the lens fit depends on the base curve of the contact lens. In that case, we have to do an adjustment in the back vertex power of contact lens by 0.25 diopter in order to offset the prism in the tear lens power. Now coming to the visual field, which is of two types, peripheral and macular visual field. Peripheral visual field means that for the steadily fixating eye, the field of vision which is subtended at the entrance pupil of the eye. So let's understand in an easy way. Suppose you are steadily fixating at a particular object. That time, whatever objects you have in your periphery, when those objects are being perceived by you without moving your eyes or your head, okay, with your eyes fixating at that object, then that is called the peripheral field of vision, which is same with both the spectacle lens as well as with the contact lens, because with spectacle lens or with contact lens, we are not moving our eyes or our neck. We are just fixating at a particular object. That time, whatever we have at our periphery, whatever things we can perceive in our peripheral field, then that constitutes the peripheral field of vision, which is remaining unchanged with contact lens also. But macular field of vision means that for the moving eye, the field of vision which is subtended at the center of rotation of the eyeball, that is the macular visual field. And with contact lens, it is the macular field of vision that gets improved. So we often get confused that which particular visual field is improving with the contact lens. It is the macular field of vision. Why? Because with contact lens, we don't find any kind of peripheral aberration. Okay, there is no ring scotoma or ring diplopia that we get to see in case of high plus or high minus lenses with the spectacles. Okay, because in spectacle, what happens? There are peripheral distortions happening, peripheral aberrations happening, which is restricting our macular visual field. But with contact lens, that hindrance is absent. As a result, the macular field of vision widens up with contact lens. Now next, coming to aberration. See, with contact lens, we don't find any significant aberrations happening, because with contact lens, what happens, our foveal line of sight is directly coinciding with the optical center of the lens, because the lens is directly placed over the cornea. So when our eyes are moving, the lens is also moving with the cornea. So therefore, it is the foveal line of sight, or the visual axis of our eyes, is completely coinciding with the optical center of the lens. So therefore, there is no prismatic effect happening, so no distortion happening. So therefore, there are no aberrations happening like chromatic aberration or spherical aberration, coma, or any other kind of distortions. Moreover, with contact lens, there is no change in image magnification happening from center to periphery. Okay, because we are only looking through the center of the lens. So as a result, there is no question of looking through the periphery of the contact lens, because the lens is fixed over the cornea. So as a result, there is no change in image magnification from center to periphery, and also there is no aberration happening. But with spectacle, what happens? In spectacle, especially in high prescriptions, the aberrations take place because of the peripheral distortion, because in case of plus power, what happens? There is pin cushion distortion happening. With minus power, there is barrel shaped distortion happening, which is also restricting our macular visual field. Plus, aberration happens due to the kind of lens material we are using. Okay, and also there is a change in the image magnification when we go from center to periphery, especially in higher prescriptions. So this is another advantage with contact lens. Now coming to the neutralization of astigmatism. Now in this, first we have to understand one concept, that there is not a very significant change in the refractive index of the precorneal tear film and the cornea, because tear film has a refractive index of 1.336 and cornea has refractive index of 1.376. As a result, the optical interface in between is not quite effective to bring about a significant change in the degree of refraction taking place. Okay, now in case of an astigmatic cornea, if the cornea is astigmatic, suppose if the degree of astigmatism is very low, in that case we can use a spherical soft lens, especially if it is going by that particular thumb rule of 4:1, where the spherical amount is 4 times more than that of the cylindrical amount, and where we are actually calculating the spherical equivalent that we are choosing as the back vertex power of the contact lens. So in that case, what happens? The soft lens will mold according to the shape of the anterior corneal curvature. So as a result, what happens? The post lens tear film is almost equivalent to 0. Okay, or even if there is an induced astigmatism, that is tolerable. Okay, but in case of spherical RGP, if you are using a spherical RGP for astigmatic cornea, then the post lens tear film gets sphericalized. Again, in this case, the amount of astigmatism has to be not a very significant one. So we have seen that spherical RGP can be used, theoretically can be used up till 2 diopter of corneal astigmatism, but in clinical practice I have seen that up to 3 diopter also, 3 diopter of corneal astigmatism also we can go with spherical RGP lens, provided that the residual astigmatism getting induced is not posing much of a visual discomfort to the patient. But otherwise, it is always sensible to use a toric lens for astigmatism, whether it is a corneal astigmatism or a total astigmatism. We are going to discuss more about this in my next presentation. Now last but not the least comes the over refraction, because after selecting the contact lens, assessing the fit and doing everything, taking all the parameters and checking everything, the last thing that we have to do is the over refraction part, because that's what will finally give us the actual power that we are going to prescribe to the patient in contact lens. So what is over refraction? It is usually done to rule out the presence of any required residual uncorrected refraction value or the value induced due to the overcorrected dioptric value of the contact lens being used. Okay, so for example, with RGP, the over refraction, the total power will be, or the ocular refraction will be, the back vertex power plus the tear lens power plus the over refraction value. But in case of soft lens, the tear lens power is 0. Therefore, we are only considering the back vertex power and the over refraction. Now, this is a very, very important thing that we have to remember all as the contact lens practitioners. That is the causes behind the disparities in contact lens practice. The first is the mistake in determining the vertex distance. I've already discussed in my presentation, in my previous presentation, how important it is to calculate the vertex distance power. So either we can refer to the contact lens power calculation formula or we can refer to the vertex chart. Next is not checking the over refraction value, which is very important, as I've discussed already. Trial contact lens power may not match or is incorrect. If that happens, then we must, after assessing the fit, we should do the over refraction also in order to confirm the power once again and also for the satisfaction of the patient. Fourth is wrongly calculating the contact lens base curve. Fifth is improper contact lens fitting. So we have to be very careful when we are checking the contact lens fit. Tear lens power often varies with the K reading. Keratometer only analyzes the central corneal parameters within 3 mm zone and does not provide any information about the corneal periphery. So in case if we find any kind of corneal surface irregularities, if that is anything significant that is not being provided by the keratometer information, then we must refer the patient for topography. And the last is the corneal molding by the lens, especially with RGP or with any kind of hard lens material, corneal warpage may happen. So that's why we have to be very careful about the lens insertion or removal, and also we must check the contact lens fit properly. So that's all for today, viewers. Hope you will understand whatever I've discussed in this presentation. Yet if you have any queries, you can definitely approach me through the comment section. I'll revert to you as soon as possible with the answers. And if you like my video, then please do like and subscribe so that I can come up later on with more such academic, informative, knowledgeable videos for you all. So till then, take care all of you. Thank you so much.